Hello, this video is on exponential functions, as shown here in the syllabus. So far in the course, we have considered linear functions, quadratic functions, and cubic functions. Now we will consider exponential functions. An exponential function is a function in which the variable appears in the power. Note that the base is the number that is being raised to a power. The example shows the exponential function 2 to the power of x. A table of values can be easily obtained from the calculator. To do this, from the main menu, select Table. Enter the function, so that's 2 to the power of x, pressing the x variable and execute to enter it. And then press F5 to set the table of x values. So in our case, we're going to start from -3 and end at 3 with a step of 1. Press exit and then press F6 for table. Scrolling down, you can see the table of values. To draw the graph on the calculator, from the main menu, select Graph, and then press F6 for Draw. The table of values and the graph show that the function increases exponentially. In this example, the function 2 to the power of -x decreases exponentially. To demonstrate this, on the graph, I'll draw the function 2 to the power of -x. Press F6 to draw the graph. The general form of an exponential function is k times a to the power of rx plus c, where k, a, r, and c are constants. Remember, the constant a is called the base. All exponential functions have a horizontal asymptote, which is a horizontal line that the graph approaches on one side, and a y-intercept. There are 4 basic shapes of an exponential function. It can be increasing above the horizontal asymptote, decreasing above the horizontal asymptote, decreasing below the horizontal asymptote, or increasing below the horizontal asymptote. The graph of an exponential function has a horizontal asymptote that has the equation y equals c, where c is the term on its own. The graph has a y-intercept at the point 0, k plus c. K plus c. Remember, the y-intercept is the point where x is equal to 0. The graph has an x-intercept, which will be the solution of the equation f of x is equal to 0. Note that the x-intercept is also called the root, or the 0. This value can be found on the calculator. The easiest way to sketch the graph of an exponential function is to draw the function on the calculator first, and then to identify or calculate the y-intercept, then calculate the equation of the horizontal asymptote, and state whether the function is either increasing or decreasing, and then finally, to make a neat sketch, add in the y-intercept and the horizontal asymptote. In part A of this question, you're first asked to find the equation of the horizontal asymptote. If we begin by stating the values of a, k, r, and c, which are 2, -1, 3, and 1, and then use the formula for the equation of the horizontal asymptote, which is y is equal to c. So the equation of the horizontal asymptote is y is equal to 1. In part 2, to find the coordinates of the y-intercept, writing down the formula for the y-intercept, which is 0, k plus c, we see that the y-intercept has coordinates 0, 4. Next, to draw the graph on the calculator, from the main menu, select Graph, and type the equation into y1. So pressing 3 times 2 to the power of, and pressing the negative button and the x variable button, and then press the right cursor to come down, and then +1. And pressing Execute to enter the equation. To set a suitable window, press Shift F3 for View Window. For this function, I'm going to set -4 for x min and 4 for x max with a scale of 1. And then for y, I'm going to set -1 for y min and 9 for y max, a scale of 2. Then pressing Execute and then F6 to draw the graph of the function, as shown. Alternatively, you can either use substitution or your calculator to find the y-intercept. The y-intercept is the point where x is equal to 0. So replacing x with 0 in the function again gives the value 4. On the calculator, this is a y calculation. Pressing F5, G-solve, F6 to get to the second page of tabs, and F1 for a y calculation. Entering the value x equals 0 and pressing Execute. Again giving the value 4. In part B, as x increases, y decreases, so the function is decreasing. Finally, in part C, make a neat sketch of the graph, add in the y-intercept and the horizontal asymptote. In this question, we're asked to find the values of k and c and to state the equation of the function. Starting by substituting in the point 0, 1 into the function, as shown, and simplifying gives an equation involving k and c. Substituting the second point into the function, and again simplifying, gives another equation involving k and c. We can either solve this pair of simultaneous equations algebraically or by using the calculator. On the calculator, from the main menu, if we select Equation and then press F1 for simultaneous. Pressing F1 again for two unknowns, k and c, we then need to enter the coefficients of the equations. So for the first equation, that's 1, 1, and 1. And for the second equation, 4, 1, and 10. Pressing F1 to solve the equations gives the values of x and y, or k and c in our case. Then substituting these values back into the original function to give f of x is equal to 3 times 2 to the power of x, subtract 2. The exponential function has a base e, where e is the irrational number 2.718, and so on. E is a special number in mathematics, a bit like pi. E is used in science, engineering, and in finance. There is a special button for E on the calculator. To draw a graph of e to the power of x, from the main menu, select Graph, and then press Shift and then the natural log button to access e, and then press the x variable for e to the power of x. and then press Execute, and F6 to draw the graph. We see that the graph of e to the power of x increases exponentially, has a y-intercept at 1 and a horizontal asymptote of y equals 0.